So, we are continuing with our discussion on various types of yarns, textured yarns, and so we go further today on bulk continuous filament. So, what we have done till now in last few lectures is that we have understood the air jet texturing, material and process parameters that influence the properties of air jet textured yarn, and also importance of interlacement or entanglement, its need, mechanism, some jet design, and how we can characterize the interlaced yarns. This is what we learn. Now what? So, we have a bulk yarn which is air jet, we have false twist textured yarn which is obviously stretch or modified stretch. This is something which is interesting, which we consider as learning from each other, technologies which learn from each other, and that is how you had the BCF yarns, and they are also commercially very successful product, like the false twist texturing, air jet texturing, the BCF also are commercially successful products. So, this technology roughly employs principles of stuffer box and air jet texturing. In some sense, stuffer box produces yarns which are in the category of modified stretch yarns. Air jet texturing produces yarns which are bulk yarns. So, how does it happen? We just recall what is happening in a stuffer box texturing process. You are overfeeding the yarn into a box. At the exit there is a pressure plate, so the yarns cannot move out. So, they bend in a manner which can be controlled by the speed as well as the pressure and also temperature of the yarn at which they are getting. So, there is a plug of bent yarn which is made within the box, and the textured yarn is brought out from the other side. So, in a way you have a pliable yarn which is being hit, which is hitting a wall and so bending, and simple process, and then of course you cool down so that this texture remains. And we also remember that this technology is being used in staple yarn industry also, staple fiber, where all the crimps that are given are by this process. It is a simple process before cutting. So, we expect that the structure of a stuffer box textured yarn would be crimped, not necessarily very uniformly, and some the frequency as well as the amplitude may not be uniform. But what happens whenever they bend, all the filaments bend together at whatever point they bend. So, you get a structure like this. So, it gives you some amount of bulk and some amount of stretch. The air jet textured yarn on the other hand is a process which gives bulk yarn. So, air jet textured yarn is a bulk yarn. What we are saying is that we will be looking at a possibility of combining these processes, principles involved. So, air jet texturing uses jets their main purpose is separation of filaments and then loop formation and entanglement. So, one of the interesting part which people learnt is that in an air jet, for various reasons, it should be possible to separate the filaments. In the previous case, you are not separating the filaments, you are bending the whole multifilament. Now, that you say is fine, one can do, but if at the same time you could also separate the filaments, then maybe you will get a different product. There is nothing called a loop formation, but crimp formation definitely is what we are looking. So, as far as the AGT is concerned, entanglement is part of the game and you produce a bulk yarn. BCF technology wants to create crimps and uses fluid jets, and therefore, the fluid jet part learning has come from the air jet, and crimp, that means you hit the wall and bend, that has come from the stuffer box, and so this has become more effective and popular. What type of yarn this will be? One technology giving me bulk yarn, the other giving me a stretch yarn. So, this is likely to be in this category, that is, it can stretch, but the difference is you have been able to separate the filaments, that is the main difference. So, using similar technology to get a product which is different. We expect a more resilient yarn than stuffer box. What it means is that the filaments after separation bend at different points. So, of course, you will have this bulk, you will have stretch. So, these are possible, but because they are not following each other, the overall bulk is larger, and so contribution towards this bulk and then compression and recovery from compression are better, and so that is what we call as a resiliency. So, these yarns therefore are very resilient and therefore are going to similar application like a carpet pile. Stuffer box also can go anywhere, but it was your staple 5 industry, because large number of filaments can be just bent. So, this difference has actually made BCF yarns more popular. This we will learn that. Another interesting thing which obviously people realize is that this technology can allow spinning process to be combined also with texturing. So, this we can discuss a little later, but therefore, it became more commercially successful and more attractive. So, you did not have 2 machines, do not have to have 2 machines, you can have one machine which can work all the things. So, the fluid that is used is hot air rather than the cold compressed air or room temperature compressed air. So, in the air jet we are using compressed air, but we are not raising the temperature. Here you are using hot air. You can use superheated steam as well. The advantage of superheated steam is that when it condenses, it passes on the latent heat to the material. So, the rise of temperature can be fast. The disadvantage is obviously that there can be water droplets somewhere and you may have to design things in different ways. But the hot air means the temperatures are high. And how high the temperatures? That would depend on the fiber itself. It's a polypropylene fiber or it's a polyester fiber or a nylon. So, based on that you will use the temperature. And suppose you are using polyester and using 190 degrees air. So, this can't be an open system where you are throwing air and it is coming out from one side and nobody is concerned. You can get burns without any problem. So, you have to have, you are going to use fluid, which is we calling fluid because hot air could steam, anything could happen there. But what it also means is that this whole environment has to be secured. You may not be interested in recovering the air so much. If you can, not an issue, because at least you have to reheat less. You take it back and again compress and heat it, bring. So, one system is that you have to have a hot fluid, and purpose is very simple. Because it is hot, therefore, thermoplastic yarns are going to be affected. So, one interesting thing also to be remembered is that this is also using thermoplastic yarns. So, PP is very popular, polyester, nylon, any one which responds to thermomechanical changes is a good candidate for this. Precautions of course will have to be taken. So, different from the air jet that is using hot air, different from the air jet that it would not be suitable for viscose and non-thermoplastic yarn. The functions that are expected from a fluid jet for the BCF is aspiration. That means it will suck the yarn immediately as it comes to the thing. So, it will suck and forward, right. So, the aspiration. Pliability, you want to make the yarn softer. So, if you make the yarn softer, the frequency of bends, amplitude can be controlled and they can be done easily. If temperatures are low or not hot, then obviously the larger bends are going to be made. And of course, this is the most important expectation, that individualization of the filaments. So, it has to be used in a manner that the filaments are not only sucked and thrown out, but they are individualized also. Then only then you will get that structure. So, common sense also says that after hot air bending, it will become pliable, so it becomes easy bending. The bent yarn must be made stable. So, there has to be a process of cooling the yarn, so that we get the crimps stabilized, and so there has to be a cooling mechanism. Do we give overfeed? Of course. Whether it is the air jet or it is the stuffer box, we are giving overfeed. So, overfeed will also decide as to what is going to be the number of number of crimps and frequency of the crimps. Of course, when you say hot fluid, there is a pressure also involved. So, this aspiration and separation, everything else, there is a pressure also involved. So, you have a pressure governing systems also. So, the question is, do we need entanglements? Air jet, one of the function is entanglement. So, using the same jet at a higher temperature. So, in air jet we do expect in BCF we do not want entanglement. So, we know how entanglement happened in the air jet texturing. So, you have to avoid that. So, how do we ensure that the filaments which have been separated being thrown out of the jet, they are pliable, but they do not entangle? Because our structure we want is that individual filaments bend in whichever way, we have no issue on that, but we still do not want any entanglement. Then the compression, extension, all that will work better. So, how do you avoid that? We have seen air jet, we have seen interlacement, some entanglement takes place. Because if it gets entangled, then it will be a different product. Yeah?
By changing frequency and amplitude of bending.
Yeah, but this is happening, this amplitude and frequency change is not a very controlled phenomena, is expected phenomena. The control with you is the pressure and the temperature. They are the control that you have. But it will be very difficult for you to say, well, this one goes only there, the other one bends here, the other one bends there. It is not there. So, whenever they strike, the bending will take. So, you are striking a wall. So, the technologies have been used principle, but they still want a different product. So, one important thing is that at the end of the jet, at the exit and during collection, there is not tension. Because if you remember, in the air jet texturing, at the end of the exit there was a tension, and because of the tension, why was the tension? Because filaments were flying at different speeds. So, you had tension, because there was a tension, you had migration, and because there is migration, so you had entanglement. So, what you have to ensure is no tension or a low tension. No is the best. Of course, we are overfeeding. We are overfeeding in air jet also. So, this is what is to be done. So, for a machine, fluid jet is important. So, some designs will be there which is simple, that you have to have some ways in which there is a divergence allowed, so that filaments not only move forward, but separate. That part of the mechanism is understood. So, the other part which is important is collection. After they have been aspirated, pliable, made pliable, and then they are separated and they are being thrown when the bending is taking place, you have to collect in a manner which does not lead to tension. So, roughly a machine may look like this. So, you have your package, you draw the package, this is the jet, the hot fluid, and this multifilament yarn is overfed. And so, separate, but as it comes out, each filament just near the exit strikes a wall. This is a roller. Let us say it is moving in this direction. The yarn is being collected, fed, overfed, but there is no nip here. You see, in all overfeeding systems, you have a feed roll which is moving at a certain speed, which is a nip. Then there is a take up roll which is also nipped. So, between these two you have a differential speed, and so you overfeed. So, this speed of this roll, this is a big roll, will be decided by how much overfeed you want to give, because whatever speed is there which is governed here, of course there will be guides and everything else, you just keep feeding, because this is sucking, it will pick up anything that you give, right. So, you give 20%, it will take 20%. Only thing is, during this whole process, it should get separated, heated enough, and then strike this drum. Drum is rotating at a speed which obviously from the point of view is taking care of the overfeed, and this yarn in some way gets collected all over the surface. Now, there can be a nip later. Now, by doing this, what have we done? The yarn has almost no tension at the exit of the jet. After that, it is over. And what this drum is going to do, it will take this crimped yarn on the surface all along and cool it also. It is a metal stuff, cool. So, expected by the time it reaches this point, it is cooled. So, the crimps that are there are set. So, what has happened? Individualization of filaments, individual filaments are striking a wall, bending, and just being cooled slowly. After this, you can do whatever you want to do with this yarn. So, you get a BCF yarn here. What type of yarn would be feeding here in this jet? POY or FDY? FDY? Why not POY? Important thing is, the BCF is a final product. There is no more intermediate step after this. Then, if you are taking a POY which is a very less oriented material, it will be bent, of course, it will be set there and then in a very, very unoriented manner. So, later on also its extensions etc. will not be controllable. So, you can use a POY if you want, but you will have to do pre-drawing. So, if you, but what is going to be fed in the jet it should be fully drawn. If you want to change, you can. I mean, if suppose you are saying, well, we are getting POY, somebody is supplying, which is possible now, most of manufacturers are making POY. They will have to use a pre-drawing system to draw and then go through this process. So, this will be a final product. Speeds are more than 3500 meters per minute. Look at the speeds that we are talking about of the false Swiss texturing, starting with 150 going up to 1200 meters per minute. Air jet texturing 600, 700, 800,000 meters. This process can give you speeds as high as this. It is a very fast process, therefore, it comes cheap. Therefore, you can do production very high and it is simple. As long as you understand the principles, it is a very simple process. You are not interested in entanglement. So, this yarn is going to be modified stretch yarn like a crimped yarn. So, it's there are crimps, so they will open. If it is set very nicely, it will go back. So, good use is being seen in the carpet industry. All kinds of deniers can be used. So, obviously, we are using a hot fluid, so morphological change is taking place. One can say, well, the time available here in the jet at this speed will be what? And jet cannot be very big. Let us say, even if it is a 5 centimeter kind of a jet, maybe 10 centimeter of a jet. What time you are spending at this speed? See? So, you are expecting things to happen and they happen. They happen because the actual change in morphology actually is a millisecond, microsecond process. So, the time which is taken is in heating the material from room temperature to a particular temperature where these changes are going to be facilitated. But actual, once you have reached the temperature where the thermodynamics takes over, it is a very quick process, automatically very quick process, and therefore, at high speeds this can be happening. Otherwise, one can always doubt as to how will you finish this process. It is true in false twist also that actually the time that is required, even if it is 0.2 seconds, most of it is in heating and not rearrangement of molecular chains. So, the rearrangement of molecular chains takes place in a very, very short period. Thermodynamics is like this, just more than 0, of course. The cooling drum could be 0.4 to 0.5 meters in diameter, which if you look at any such machine, whether spinning or thing, looks like a bigger diameter, right, because you have to spend some time. And during this whole process till it is set, no tensions. On one drum, because drum is big and you are rotating it whatever, so fixing so many drums for every position, that too large drum. So, you say, well, why not have more than one jet being cooled on one drum? So, it's a fast process. So, sometimes people use 2 tracks on a drum or 3. So, yarn comes, one of them is guided onto one track, the other is another track, the other another track. So, the arrangement have to be done of hitting and taking in such way the gravity does not let the yarn fall. It can be done, isn't it? This is the drum. if he is moving in this direction. So, if the hit is here, so it can't fall because it is being taken away, and then from here you collect straight. So, it can say. Otherwise, if other things are being seen, then you can always make a perforated drum which can suck cool air and can cool and not let the yarn go out of. Why you should appreciate? Although it is a large drum and the speeds are, but speeds are high. So one should not have issues of under less tension. See, if speeds are high and tension is high, winding is okay. Right? It is not a winding drum, it is a drum which is cooling. So it is obviously rotating at a much slower speed, but how much slower? Surface speed. Just calculated because the overfeed. That is all, it is just adjustment you have. So it still be rotating at fast speed, but because diameter is large, so it can be, so one around. Now this is the intermingling part of it. So you know the difference now, it is not air jet texture. So would you require intermingling? Yes. If you require a false twist, you require a fully drawn yarn, you require a BCF also. So interlacing jets will be fitted before binding, and so you get what you want to get. So multicolor is not a very different thing. You have a colored yarn, so colored yarn will come, no problem on that. So one can have 3 different colored yarns, 3 different tracks, yellow, green, blue, being collected 3 different packages which are yellow, green, blue, no problem, which is a monocolor of a different color. But one can think of that, you can mix also, you can separate and mix and get some mixed color. So people sometimes are using this, that will give you a multicolor effect in the yarn itself, because during cooling or otherwise you collect them in a manner, so they get, theoretically you can feed also. So monocolor of course means whichever color is the mono, or the other 3 color, some of the companies may be offering option of 3 colors. As long as it is a package which is a colored package, it does not pose much challenge. The challenge comes at a later stage. Where? So before we go a little further, just an attention. You have a spinning process which we saw, high speed spinning. High speed spinning means 3500 you get POY, 6000 you get fully drawn yarn, so on and so forth. But there is a process which we call a spin draw process, which spins at a relatively low speed. So spinning speed is not high, but as it is being drawn along these godets, the speed keeps on increasing. The speed here could be more than 3500 meters per minute. That means at the end of this whole process called spin draw, you would have a fully drawn yarn. This type of yarn is quite popular in tire cords, as tire cords, spin draw yarn. Now, there is something which strikes us here, that is spinning and drawing combined are running at speeds which are quite high. Our BCF machine capability is also of same type, right. If there is the same time, they can combine. That is, the yarn can be fed at a very fast speed and then again taken out at a fast speed. So, here at the end, this is a fully drawn yarn. This is the input. So, a spin draw machine can become an input directly to the BCF. I mean, we can't say this, that you can put a spin draw system or any other system and combine it with false twist texturing. No way. Speeds are too different. So, you have a separate package and you do separately. But here fortunately, these process is very fast and the other process is very fast, comparable speeds, then you can combine. Anyway, FOY is at 6000 meters per minute, that is by spinning speed. This is too high, people do not use that and can say, well, why can't we use that? That is not done. POY we do not want to use, right, otherwise it is a combined POY machine with this. POY has to be drawn and therefore a spin draw process. So, for the first time you have a process called spin draw texturing. You can combine the spinning process with the BCF. If you can, then you do it. So, most of the plants would actually be like this, but separately also you can do it, no problem. But if you want to combine, that would mean that you have enough production that you will be able to sell. So, you can work it out, because the moment you have spinning attached with you, it is a 24/7 operation, non-stop. You do not stop a spinning process, because the moment you stop, everything will be choked. So, it is not stopped, 24/7 keeps running, and so your machine also must keep running 24/7 for texturing if you are combining, or you have an option, whenever I want to combine, I combine, otherwise I will wind, that is possible. So, we stop here and with one information, that you have a process which is running at a very high speed and therefore production is high and the cost is less, cost of the product, because the process cost is less, and so good amount of thing is being produced. You can use it for any purpose, but carpet pile is one of the good applications for such type of yarns. High heavy denier yarn could be utilized for this. Thank you.